Login accepted.
Okay, so welcome back, everyone. I hope you guys have a great lunch. It's nice to be back. In fact, it's been a while since I have been to a conference, and it is kind of mind-blowing to realize that people are not floating heads on a Zoom call. Welcome to the State of NoSQL in 2021. My name is Denis Rosa. I work as a developer advocate at Couchbase. For those who never heard about Couchbase before, we are a NoSQL database that stores data as JSON. And Couchbase is kind of focused on this, on performance at scale. So this is usually where Couchbase really shines. I have been a developer for quite a long time, but lately I have been working as a developer on the NoSQL space. So I like to define myself as developer that understand databases really well. This talk was actually created when a friend of mine called me, and he told me, hey Denis, I am in charge of designing the architecture of a big project here on the company that I work for, and I don't think that NoSQL could be a good we could have some use cases where NoSQL could be a good fit, but I haven't used NoSQL for like 8 years or so, and I'm not aware of what happened there during all this time. And then we joined in a Zoom call, and he started asking a lot of questions, really good questions, by the way, and I just realized that, okay, I think this is one common, many developers out there have roughly the same questions, and I decided to record the conversation and kind of create a talk around that. One of the first things that this friend of mine asked me was, okay, I remember back then, roughly 8 years ago, a lot of people used to say that, okay, NoSQL databases were designed to replace relational. Again, yeah, those things are what marketeers like to say, but the reality is a little bit different. Think about those two churches here, right? The one in your left is a church in Norway, which was built roughly 300 years ago, and the one in your right is a church in Russia, which was built around 500 years ago. The thing that those two churches have in common is that they were all built just using those wood joints, right? So it is kind of a remarkable achievement to think that you can build something that complex by only using wood connections. But we do have some easier ways to build stuff, right? We have something called nails. And nails have been there for a while, right? At least the oldest evidence of a nail dates back to more than 5,000 years ago in Egypt. And nails are awesome, right? We can build a lot of stuff by using nails. And if you take care of your construction, it can last a few hundred years. But we cannot build something like a Burj Khalifa just with nails. I'm not a civil engineer, but I guess that you will need something like screws and bolts and rivets. Talking about screws, they have been also out there for a while, but only by the end of the 18th century was when Jess Ramsden created the first lathe machine capable of building screws at scale. And that's when they became popular. An interesting thing with nails and screws is that even though we created nails, nails didn't become legacy, right? We are still using both. In reality, most of the buildings out there, they use both, right? They are using bolts for some stuff, rivets for other stuff, screws, and nails. So most companies, most buildings will probably use a combination of all those things. This is exactly the same, we can use exactly the same analogy with databases. There is no legacy database. They are all designed for specific use cases, and they will be great on that. And the future is more a combination of all those databases instead of one database to rule them all. Another question that my friend had was, okay, I heard back then a famous NoSQL distributed database, the one that had some green logo, told me that joins are slow. Is that still true? Are joins slowing in databases in general? Well, in reality, yes. Making joins are slower than not doing joins, right? But in a relational database, as long as you have your tables properly indexed, your joins will take just a few microseconds to run, right? So potentially, if you have problems with joins in your database, you don't have a problem with joins. You have a problem with indexing. And you know where joins could be problematic? In distributed databases. Because if you think about it, in distributed database, there is a chance that parts of the data will be in one node, and parts of your data will be in another node, and then your join will cost at least the latency between those servers. And in an EC2 instance running on AWS, if you haven't network optimized those two instances, I would say that the average latency will be 150 microseconds. So your join in a distributed database will cost you at least that, because, well, that is the latest between those two nodes. Which is not great, I understand, but also not terrible, right? This is probably you spend more time on your application trying to parse the data back from the database than just than all the time that the database spent making those joins. However, at scale, and if your data is is spread between multiple nodes, then it might become a problem, right? So what most NoSQL databases did was, okay, let's use different data model then, right? Let's try something different. If you use, for instance, aggregate roots in domain-driven design, so use something like, okay, on my application, I treat the user as a whole. So in my database, let's use the user as a whole, store the user as a whole as well. So getting the user back from the distributed database back to your application is as cheap as in a relational mode, in a relational database. So that's why some NoSQL database, they will pick a different data model because they want to reduce the amount of joins, cross-node joins that you have in your database. Another interesting thing is that this data it also is more developer friendly, I would say, because this is how we deal with data in our application, right? Because it's already we treat the user as a whole, and when you go to a relational database, we have to split in different tables and tables in general. So this approach here is a little bit more comfortable for developers, I guess, but it does take a while for you to change your mindset. And okay, this is great. We reduce the amount of joins. However, there are still some joins here, right? Let's say I want to join the user with a product, for instance. And for those cases, because we are talking about more like 30, 20, 10% of your application, then we can create indexes that will solve those latency issues. And this is, I mean, a good portion of the NoSQL databases are pretty much using this kind of approach. And this is where we need to talk a little bit about the kind of a new trend, which is the NewSQL databases. In fact, this is yet something that is, I would say, people trying to give new names to things that have been out there for a while already. In fact, NewSQL is something called a distributed relational. And a distributed relational is a little bit problematic because, again, if you remember, data in a relational is distributed. So your user, quite often, like the representation of your user is spread in between, let's say, in most systems, between 15, 20 tables, right? And what happened when you try to do that in a distributed database? Yeah, a lot of cross-node joins. And that's one of the biggest problems with NewSQL database. It's not a design flaw. It is, okay, this is how they were designed. They are focusing on different use cases. But NewSQL is not a solution as well. Like NoSQL is not the ultimate solution. There is no such a thing. Right? It is just a different approach. So one thing that you should keep in mind is that, yes, NoSQL could be cool, but you're going to spend a lot of time, like the database itself tries to implement some smart ways of sharding data to keep the data together. And they also, some of the NewSQL database, they have a kind of a watcher that try to understand or see the patterns on your database and move data that are commonly queried together to the same node. Those things are cool, but there's a price to pay, and quite often is more memory, more CPU. So, but yeah, we might agree that, okay, maybe if you are using NewSQL, you are not looking for performance. Maybe the reason why you picked NoSQL is because NewSQL is because you want something called consistency, and this was yet another question that my friend had. Like, okay, I heard that relational and NewSQL, they support this this ACID consistency, and NoSQL had this base consistent. And this is where we need to start talking about this kind of a new generation of NoSQL databases. When I say new generation, or second generation, I'm not talking about new databases that were created, let's say, 3-4 years ago. I'm talking about the old databases that at this point have been completely rewritten. Just an example, Couchbase was designed roughly 11 years ago, right? Yeah, something like that. And we were a fork of CouchDB with a fork from MainSQL. So it is kind of a database that, okay, is memory first, and then we synchronously store data to the disk. And at this point, we have completely rewritten all the old code from CouchDB. Most of the concepts are still there, but the code from CouchDB itself has been completely replaced. And yeah, we still have some CouchDB reference on the code, but it's mostly because, okay, maybe we decide to not refactor the whole thing. And I don't think that databases are very similar to airplane engines, right? They do take some time to mature. So, like an airplane engine, databases have not, they don't have a lot of space for failure, right? If a database starts to losing data, yeah, it is. If you have a better reputation, it is enough to make the company itself go out of business. And I think what happened on the last few years is that NoSQL database, they finally have some maturity, right? Most of the database now have a bunch of integrations They might not be the tools that you are used to, because most of those tools, they expect the relational, they expect data like tables, and some non-SQL database, they use a different data model. But there are very similar tools that you can use as well. Most of the non-SQL database, they also have a higher failure tolerance, because they were designed back when cloud or even distributed environments were already a thing, which is not not the scenario when relational databases were originally designed. Most of them are also tested on critical scenarios, because, well, if you don't have a critical scenario, potentially you would just be using a relational database instead. And on average, picking a NoSQL database will give you the return, will pay off on the medium and long term, right? From my experience, my personal opinion, it will pay off in somewhere between 2 years or so. Because for the first year, relational will be, in pretty much all cases, will be good enough, because most companies, the data don't grow that fast. But I have seen many cases where companies, after 2 years, they had to rebuild the whole thing, because the growth is faster than they can grow their system. Most databases also have some professional support, right? Because you have someone you can ask for help, and also somewhat good documentation, because they have been there for a while. Not as much as relational, but still something good. And lately, a few databases added support for ACID transactions and cost-based optimizers. Talking about transactions, it's important to highlight that your data model might affect your need for transactions. So in a relational database, if you want to insert a user, you need to start the transaction, add a user, add roles, add preferences, and then finally commit the transaction. If you have a different data model, for instance, in this case, JSON, your operation is already atomic, right? Or you insert the whole user, or your operation will fail. So you don't need an actual transaction for that, because the data model itself already gives you some sort of atomicity. And this is the same case for other data models as well. Cool. But as we are talking about transactions, we need to mention consistency models. So Jepsen has this amazing graph here that lists some of the consistency models. The lowest one are the less consistent, and the higher one, in this case, the strict serializable, is the highest kind of consistency that you can get. Of course, having a database that has strict serializable is a very expensive operation for the database itself, because to make everything always consistent. But in some cases, it is something definitely needed. When we decided to implement transactions in Couchbase, we decided to support monatomic atomic views and read committed. Right? Those two, according to our research, are the ones that developer would be good enough for our database and for the scenarios that the developers need, and it would not put a lot of pressure on the database side. If you wonder, okay, how good monotonic atomic views and read committed are, well, this is the default on Postgres, MariaDB, MySQL, and SQL Server. So if you never changed your consistent model on your database, this is the one that you are actually using. Talking about how we implemented transactions, we picked two approaches. The first one is kind of a transaction that is implemented on the SDK level. So it's kind of the SDK is the one responsible for managing the transaction, which, to be honest, under the hood is a plain old two-phase commit, right? So you can actually use the same approach to add support for transactions in any kind of database, because it's all done by the SDK. So the SDK kind of, whenever you make a transaction, the SDK caches some of the changes, and then when you query stuff, it will filter the data to make sure that, okay, you can read what you tried to write. And the good thing is that when you implement a transaction on the SDK level, you have no central coordinator, which is in most databases, if you have a transaction and you need to read something, you need to go through a central coordinator to ask to read that data. And also, no single point of failure, right? Because the clients are the ones managing the transaction. However, okay, this is not something that might fit all use cases. So we also implemented in NoSQL. So NoSQL is how Couchbase essentially is the query language that we implemented. I will talk about it in a bit. But yes, when you go to NoSQL to execute transactions, yes, then we have a central coordinator, and this will naturally add an overhead in the database as well. When we talk about other databases like MongoDB, so MongoDB changed their storage engine. I think it's Tiger something, I forgot the name. But they added support for multi-version concurrence control, which is how, which is a mandatory component to implement transactions when you have when you need a higher level of consistency. So, for instance, on MongoDB, you can have a consistent level like snapshot isolation, for instance, because with multi-version concurrence control, you will keep multiple versions of your data while the transactions are being executed. This is cool. This is what other relational databases do. But of course, there is, like everything else in life, there is some overheads that you need to deal with, which might translate with more memory, less throughput, and other stuff. There is no right or wrong here. It is just the scenario that they decided to go after, which I guess sometimes MongoDB is targeting relational database users and scenarios that, okay, yeah, we want to replace your relational. And that's why they decided to go that route. Cool. While Redis, they do claim that they support transactions, but they have a specific way of implementing it that, to be honest, kind of bugs my mind, because they don't support rollbacks, which for me is the main reason why developers in general decide to use transactions, because they want rollbacks, right? They don't want to leave any inconsistent state in the database if something fails. They do have an article in their blog saying why you don't need rollbacks in Redis, and yeah, definitely recommend you guys to check it out later. But it's important to highlight here that, okay, that's cool. When you see that some database support transactions, there is a lot of things that you should check as well. Like, okay, which kind of transactions you have there, and what kind of support, what kind of guarantees you have as well. So if you just assume that, oh yeah, we support transaction, there is a lot of, the devil is in the details, right? Cool. Another important thing is that the cap theorem is a little bit obsolete right now, so I don't think that we can still use this thing. Most of the, I would always prefer to use the Jepsen graph instead, because in theory, yeah, Couchbase, Mongo, Redis, they are all CP databases, and Cassandra, for instance, is a database that is AP, right? However, you can use Cassandra as a CP database, right? They allow you to have queries, execute queries that are consistent. Might be not the ideal case for them, but they do support that. And for instance, in Couchbase, you can query data that will be, let's say our queries could be eventually consistent if you want to. So there are many shades of gray here. Like Mongo can also be a CA database or AC database as well. So I don't think that theorem can be used anymore. And yeah, it's just a highlight that. So if someone says CP, this is not enough to define a database nowadays, especially in NoSQL. But it is important to always pay attention to the defaults on the database. They will tell you a lot about how the NoSQL database was designed, right? So if you just pick the default approach, and it will tell you, okay, yeah, this is how we designed the database for. In theory, it is the fastest approach. So most vendors will say, okay, the default choice is the fastest one. Another important thing to think about while working with databases is do not treat databases as black boxes. Sorry. I think because of ORMs like JPA, Hibernate, most developers started to ignore the database. Some of them are even proud when they say that, oh yeah, I can migrate from MySQL to Oracle to Postgres with no breaking points. For me, it means that, okay, you are not using the most of your database. And the same here, and this is especially critical when you're dealing with NoSQL databases, because some of it might affect your data model. So maybe for some databases, they might not be as good on doing joins. For others are fine. So for some databases, you might need to, like operations, use the key value store. For others, you have to go to the master and to the slave. So it is important, like if you decide to use a NoSQL database, the first thing you should do is understand the underlying infrastructure. Just don't treat this as something that you store data and they will figure out how to do it by yourself. A lot of the performance of the database in distributed systems is defined when you're coding your application. Well, as we are talking about databases in general, I think, sorry. It is important to also talk about demographics in general. So if we consider that everything that is not relational is a NoSQL database, we have over 200 NoSQL databases nowadays, which is quite a lot. Some of them are definitely not good, and probably will be forgotten. But when we talk about popularity, you see that relational still rocks, right? And this thing here kind of tells me that we're still overusing a little bit relational right now, and other database could do a better job. So relational is the most popular one, followed by document stores or document databases like Couchbase and Mongo, because they are, in most cases, the closest you can get to a relational. And then you have key value stores, and then a few others. And because we are overusing a little bit relational, at least the forecast is that, okay, in the next few years, NoSQL will still grow a lot, and I will explain soon why. When we talk about which NoSQL database you should use, there are, of course, some choices that, okay, you probably, some safe choices. The most popular ones would naturally be the cloud providers ones, so Dynamo, Cosmos, and the Firestore. And then we also have the open source ones, right? Which is Mongo, Elastic, Couchbase, Redis, Cassandra, and so on. I kind of added just one of each category here, just to give you guys a few examples. But if you really want recommendations of or comparisons on which NoSQL database should I use, there is some good reports out there, like the Forest Wave. They do have, I mean, although most of us don't like those kind of comparisons, they do highlight the strong and the weak points of each database out there. So last time I read, it was very accurate for a lot of databases. Some of those reports might not include a few databases because they have a limit of, okay, you need to at least have a revenue of X millions per year. So yes, I'm talking about Gartner here. But there are a few others that are fairly good. So if you want to have some decent comparison, or at least something that is not marketing focused, yeah, I definitely recommend you guys checking something like Forest Wave and a few others that evaluate those databases. We also need to talk a little bit about the elephant in the room, right? Which is in the last years, 2 years or so, a lot of some cloud providers started offering some open source databases as a service on their infrastructure. And this approach, although it's totally legal, impacted the performance of, I mean, the revenue of some databases. And since then, they decided to change their licenses. So Mongo changed their license to SSPL. Redis created their own license. Elastic also, in a few months ago, decided to change their license as well. And I mean, I'm no one to judge them. I do think that there is indeed a problem with open source and how we support those big tools. But I am concerned a little bit about where we are going with those big open source tools. Yeah, and there is no easy solution so far. One thing that we have been doing is to move the license to BSL. So BSL essentially gives you the rights to your, you have kind of a closed license that is converted in 2 to 4 years to open source. So at least you have a few years, or like 2 or 4 years to get the benefits of your intellectual property, and then this will be reverted back to the community. To be honest, I don't know if this is the right approach, but it is at least the direction of what some databases have been moving. And yeah, and let's see what happens in the future. But so far for me, looks like most databases will move away from Apache 2, and they will still be free, but not open source for a given period of time. And yeah, and then it's up to them to decide when. Another important thing that is happening in the NoSQL world is, okay, how do I manage a NoSQL, right? I guess this is, for DBAs, this is a pain in the neck. Because the developers usually are not afraid of using different data storages, but for the DBA, when something goes wrong, yeah, they don't know how to fix that. And NoSQL database have been aware of that for a long time, and they decided to create their own database as a service solution. So if you're starting with NoSQL, I do think that this is one of the best ways to start, like picking some database as a service solution, because you don't need to understand all the complexity of how to maintain the database. And in the last years, yeah, you probably are well aware of that Couchbase has Couchbase Cloud, Mongo has Atlas, Neo4j has Aura, and so on. Another choice that is becoming popular nowadays is, sorry, let me just, is to run your database on Kubernetes with operators. So operators are kind of applications that you could develop yourself an operator for Kubernetes, or you can use a community-developed one, or you could use an official one provided by the database vendor. But the magic of operators in Kubernetes is that once you deploy the operator, it will automatically start managing the database for you, right? So, for instance, there is, and not just NoSQL, it also applies to relational database as well. And I do think that this will probably be the future for database in general in the next few years. So we are all going to migrate to Kubernetes and operators. Most people will stop using database as a service. Because when you deploy, I mean, you have a lot of flexibility when you deploy your database on Kubernetes, right? Because you can configure as you want. And the operator will watch your cluster. Of course, you have to install the proper operator for that database. But for instance, let's say in Couchbase, when you install Couchbase on Kubernetes and install the operator, it will automatically run backups, recover from failures. It will automatically provision a cluster for you. You can, let's say, you can hibernate your cluster if you want to. And it's the same for relational databases, right? Like when you install MySQL using the Percona operator, yeah, it will automatically do backups. You can configure, you can properly configure the database. And in some cases, they can even upgrade the database version for you, which is, for instance, how Couchbase works. I have a talk just about that, and in fact, I presented at DockerCon this year, just talking about, hey, why containers and databases on containers and Kubernetes and operators are a fairly big thing. And I do think that this is a database, this DBaS is the screw-cutting lathe machine for NoSQL. So now that we have the management part of NoSQL taken care of, NoSQL database in general, they tend to become fairly popular because they're afraid of maintaining, the NoSQL is gone. One big problem with NoSQL database nowadays is that it is very hard to migrate from one NoSQL database to another. So if you need to migrate, let's say, from Cassandra to MongoDB or from MongoDB to Couchbase, you might need to rewrite your whole persistent layer. And this is very, very problematic. Each NoSQL database nowadays decide to create their own query language. And yeah, when you migrate from one to another, you just have to rewrite the whole thing. So in order to fix that, some researchers back in 2015, one thing that they realized is, okay, people love SQL, right? Everybody likes SQL. We know that SQL works, have been working great for almost 50 years. So what we need to do in order to make SQL also work with hierarchical data. So let's say we have JSON, YAML files, XMLs, or wide column databases. What are the things that we need to add on this language to make the same query run in a relational and NoSQL database? And finally, they created they published this paper called SQL++, which is a new standard that we are pushing, like community is pushing in general. Since then, even the father of SQL itself, Don Chamberlain, decided to join this movement. Don Chamberlain and Raymond Boyce are the guys who published this SQL paper. And there are a few databases implementing and pushing this standard as well. Of course, like everything else in databases, they move slower than the rest of slower than languages and frameworks, but it is something that is starting to get some traction. SQL is not that different than It's not that different than what you're used to. So the same query in SQL also works in SQL++. The only difference here is how you insert data, right? And it will be specific to each database, because maybe you are inserting data in a database that stores it as YAML file, or a database is white column, or a JSON database. But all the rest is pretty much the same. The deletes, the group bys, the average, and the delete, the updates. Of course, there is some extra keywords that help you to traverse the document and just get what you need. But as a matter of fact, they are very similar. This, for instance, is a comparison on how a query in SQL++ versus the same query in the Postgres JSON syntax. And you see that, okay, even though I am the one who wrote this query on Postgres, whenever I go through this, I still kind of complicated for me to understand what's going on. While on the SQL++ use case, yeah, it's pretty straightforward. If you haven't mentioned that this is not SQL, this is SQL++, probably you guys would think that the SQL++ one is a new syntax, and the Postgres one is not SQL. However, yeah, this is not a standard yet on most NoSQL databases. One fix for that is, okay, if you are starting with a relational database, or you are using a NoSQL database, you want to make things a little bit easier to migrate to another, I think that Spring Data is a good fit for that, or any other kind of ORM mapping that can abstract the database. Because Spring Data do support, let's say, Neo4j, Cassandra, Couchbase, MongoDB, Spike, and all others. And you can, because of the approach that we have on Spring Data, it's easier to, you can leverage a lot of the code from when you are migrating from one NoSQL to another. Finally, I think it's important to remember that, yeah, databases, they are converging. So you see NoSQL databases are implementing transaction support. Let's say JSON, Postgres has support for JSON, extending the support for JSON. So you see a lot of those databases are copying features from each other. However, you should not compare them by just checking boxes, because they have completely different scenarios. So great that Postgres has JSON support. There are a lot of use cases that will benefit for that, but if you try to use that as a NoSQL database, you're going to have a bad time. Same thing for, let's say, Couchbase or Mongo. If you try to use that as a transactional database, not ideal as well. So I think one thing that we need to start talking more is data storage in general, because they play a crucial role on our application. I would say a good portion of the performance of our application comes from the database. And it is something that we need to, in the past we treated databases more as a black box, and we need to start discussing about picking the right database or data storage for your application. Well, this is what I have for today. I hope you guys like it, and if you have any questions, feel free to ask, or just stop me on the corridors. Thank you very much. Yeah. Okay, so the question was if, databases are stateful applications, And containers are designed to be stateless. And yeah, that's why a lot of people bashed when we start talking about using database, run database on containers, and what happened when you need to recreate your cluster. Well, it depends a little bit of the database you're running. So most of the operators, they are stateless, so they store their state on etcd. And if, for some reason, if your cluster goes down, okay, you can bring the cluster back, and the operator will read the data back from etcd. If you lose the data on etcd, well, you're screwed anyway, so there is not much to recover from that. And most NoSQL databases, they also they will use. That depends on the database. So relational database in general, they will store the data on a persistent disk. So they will use standard volume claims. For some of them, you will need to use a remote persistent storage because the disk needs to be. You need to execute some. You need to back up the data there. For other databases, for instance, let's say Couchbase, we already have replication internally on the database. So database, you can configure how many replicas you want of your data. So you can use the local persistent storage for that. And the database will take care of making sure that you have copies of that. But in general, the operator will save the state on the etcd. And that's how you guarantee that, OK, even if the cluster dies or something like that, it will recover the state from there. Mm-hmm. So yeah, it is more about how do I migrate. The question was, how do I kind of migrate from one cluster, one Kubernetes cluster to another? So because maybe it's like, I don't know, you need to upgrade a cluster and you want to move your data out or something like that, or you want to move from, let's say, GKE to EKS. Yeah, it is indeed problematic when you need to move the clusters. Some databases do have support for, I would say, cluster, at Couchbase we call cross-data center replication. So ideally, you would spin up a new database there. Some databases allow you to replicate the data, and once you have this cross-data center replication working, and all the data is replicated, you can shut down this cluster here. But in our case, you can do this as the database is still fully functional. But in some databases, you might need to, yeah, okay, let's stop the database here. The database will not be online anymore. Let's move the data there, and then spin up the cluster there. So migration for stateful applications is still problematic, could be problematic. Any other questions, guys? OK, so thank you very much. And yeah, if you have any questions, feel free to ping me here. Thank you.